Hey everyone, this is Jarrad VK3BL Bravo Lima, and tonight I want to talk about my Palstar AT2KD differential antenna tuner. I also want to talk a little bit about how T-match antenna tuners work and show you how to find a match from scratch, especially if you don't have a starting point. But before I do that, I just want to talk a little bit about video quality and why I'm hoping this video should be so much better. Now, previously when we were doing close-in work, such as recording the front panel of a radio, maybe for a video manual or something like that, we used the same camera we use for everything else, which is the Mevo Live Event camera. Now, I always found that I could never get the focus I wanted out of it, and it didn't matter how much light I had in the room, it just always looked like there wasn't enough light. So instead, what I've done is I've gone and got a little clamp, I suppose, that clamps onto my iPhone XR, and I've also got a little adapter that plugs into the lightning port. And basically what that does is it lets me plug in an 8-channel Yamaha mixer via USB. And that's nice because instead of having, say, a lapel mic, I could plug radios directly in, but in this instance, I've actually got a huge Rode Procaster dynamic mic in my hand, and that's going straight into the little iPhone. So I think that's pretty cool. Let me know in the comments what you think of the quality of this video compared to some of the previous close-in videos we've done. So without much more jibber jabber, let's talk about the Palstar AT2KD. Now this is, I should point out, the older model, which does actually have a switch for 160 meters there, which actually chucks in a little bit of extra inductance, a little bit of fixed inductance for 160 meters, whereas the newer version has a, I guess, revised roller inductor, and according to Palstar, doesn't need that. Some people say that this model's better, other people say the other model's better. I guess it really depends on your needs and the type of antenna you've got, but I'm quite happy just to have this one. I picked it up second-hand in fantastic condition. Our dollar is terrible at the moment, and I'd suffered an automatic antenna tuner failure here, and I was lucky to pick this up, and I'm very, very happy. I've owned Palstar equipment in the past. I have owned the AT2K, which is the 2-knob 1-crank version, also a T-match tuner, and of course my main station uses the Palstar HF Auto, which is basically a Palstar AT2KD, but instead of, well, one, it's got much bigger components, and instead of having knobs, it's got little stepper motors connected to them, and it does all the tuning for you. It's it's quite a nice bit of a machine. It kind of sounds like an old IBM PC hard drive with a stepper motor, but anyway, I digress. So why Palstar, or why am I such a fan of Palstar tuners? Basically because of the quality. The first thing you notice when you look at a Palstar is just how thick the casing is, and it's powder coated, it's not painted, it really holds up, and I don't know whether it's just the price of the things or what, but even secondhand, the people who buy Palstar tend to look after them. So I don't know whether the gear just holds up or people just take care of it because of the price. But I've had 3 secondhand. All my Palstar gear has been secondhand, and it's all been in exceptional quality. So I think Palstar gear is a tuner for a lifetime, and I can't imagine owning anything else now. I'm not saying all models are made equally. I don't agree with the fact that there's an input balun on the AT4K, but I realistically in Australia, an AT2K is all you're going to need. I mean, AT stands for antenna tuner, and 2K stands for 2 kilowatts PEP, or I guess you could also think of it as 2 kilowatts input power. So I'd basically say that an AT2K or AT2KD is a, depending on your load, and you'd have to have a pretty sane load. You couldn't have, 20 to 1 SWR or something, but it's about a 1 kilowatt continuous antenna tuner. So it's, quite a high power tuner, and certainly more than enough for a VK running an amplifier. And for someone who's running barefoot, you'll be able to load up literally anything and you won't be able to overheat this tuner. And I guess testament to that is the fact that when you're tuning, you can actually run up to 100 watts into the thing and it won't mind. So, that gives you some sort of idea of the power handling of these tuners. So, I guess I should probably talk a little bit about the type of tuner. Now, it's called a T-match tuner. And even though it's only got one knob, and I'll explain why, but your typical antenna tuner, and there's a really good video of how to use a typical T-match tuner on YouTube. It's a Palstar AT2K. It's on the channel name November 1 Quebec. And although it's an old video, it is a really good video on how to use a tuner, a T-match tuner. But basically, you've got a capacitor on your input, you've got an inductor shunted to ground, and then you've got a capacitor on your output. And that's basically called an unbalanced tuner because it's, it's not differential. It is, you've got ground and then you've got all your signal on one wire. So it works perfectly from an unbalanced rig, obviously. If you want to drive a balanced antenna, you should use a balun. Some of the Palstar models did come with a balun in them, but the newer models don't, and they actually recommend using an external balun, which is what I recommend too, because I like to wind my own and make sure that I'm using a one-to-one balun designed for the antenna that I've got in the air. So I don't mind the fact that it doesn't have a built-in balun, and I don't consider that an advantage anyway. Anyway, I digress. So the fact is, it's an unbalanced tuner. So I guess you're sort of sitting there thinking, well, if you've got a capacitor on the input and a capacitor on the output and an inductor, how can you have a two-knob tuner? And what does differential mean? And basically what it means is they've combined the input and the output capacitors. And the way they've done that is they've made the stationary bottom half of, let's just say bottom half of the capacitor, they've connected that to the input. They've made the rotating vanes of the capacitor connected to the inductor, which then goes to ground. And the top, or the output of the capacitor, they've connected to the output. And so it might be a little bit hard to imagine, but basically what you've got is, two capacitors in one. And depending on where your knob is, the vanes are either fully meshed with one capacitor, or fully meshed with the other, or somewhere in between. And that's why it's called a differential tuner, because when you take capacitance away from one capacitor, say the input, you're giving it to the output and so forth. The cost of that is the tuning range is a little bit more limited than, say, a traditional T-match where you could, for example, have full capacitance on the input, full capacitance on the output. But the reality is there are very few tuning situations where you're going to need to do that. And having owned a HF Auto and the AT2KD, I haven't found one anyway. To give you an example, with 160 switched in, this tuner can actually tune my G5RV up on 160 meters. And although that's, it's completely and utterly electrically short and a silly antenna to expect to work on 160, I have actually managed to, have a FT8 contact on 160 meters from New Zealand with this tuner. So it just goes to show you, I guess the matching range you have, even though it's considered a compromise. Now, I should add at that point, the more you do silly things like try and match a G5RV for 160 meters, the lower power handling your tuner has. The whole concept of a tuner having a certain level of power handling is quite flawed, because it really depends on what you're trying to match, and most particularly it depends on how much current is flowing through the inductor and across how many turns. So basically the size of the inductor, I guess, determines how much power an antenna tuner can generally handle. The other thing that determines it is the spacing in the capacitor vanes, how far apart they are, because if you try and tune too crazy a match and run too much power, you get a large voltage build-up and you'll get an arc over on the capacitor. It's probably something people have heard before when trying to press something silly like a G5RV into service on 160 meters. So, that's, I guess, the nice thing about a manual tuner is it does sort of give you some level of feedback when you're doing something silly. I've never managed to damage a manual tuner, but I have killed a few auto ones in my time. And that's sort of how I ended up with this one, actually. But anyway, I digress. So that's, I guess, a little bit about antenna tuners. And I guess the T-match, that's the capacitor input, capacitor output, and inductor shunt to ground, unbalanced, is the most popular type of tuner on the market. If you buy a manual, that's almost certainly what you're going to get unless it's otherwise specified. Even a differential version, such as this one, will have differential in the name. So if you just buy an antenna tuner, it is almost certainly going to be a 2-knob, 1-crank T-match tuner. So anyway, I guess let's get on and show you how the thing works. So first of all, I've just got to balance the microphone on my knee here, which is going to be a little bit of a challenge because I haven't quite finished setting up this shack just yet. So let's see how that goes. All right, so as I said, because this is quite a sizable antenna tuner, it can run up to 50 watts in. And, you might say, well, why are you running? Well, it can run up to 100, but why put 50 watts in? And it's basically because if you don't put much power in, the meter, the meter won't give you an accurate SWR reading. So you do have to run a little bit of power, unfortunately. I've gone and picked somewhere dead. In this case, I've gone just to around 14,185 or something like that. Had a listen beforehand, and there's nothing there. We'll just confirm that again now. Yep, nothing but static. So at the moment, I've got it set to bypass because you've got direct here. All this side is direct. When I say bypass, it's set to coax 1. That means the input of the radio is connected to coax 1, but it's bypassing all the tuner components. We'll move that round to coax 1, just like that. And now I will send a carrier through there. And you'll see the reading on the screen. So in this case, the SWR, according to the meter, is something like 5. It looks like you've got about 20 watts of forward power, and I don't know, or maybe 12.5 of reflected. So not a good operating situation, and I dare say the radio is throttling back somewhat. It's only putting out 25 watts, so it doesn't want to hurt itself. That's the nice thing about modern radios. They will throttle back, so don't be scared to run a bit more power. Now, I guess this is where you need to understand two fundamentals about antenna tuners, and that is, as you go down in frequency, you generally require more inductance to solicit a match, and as you go down in frequency, you also require bigger capacitors, generally speaking. Maybe not more capacitance, but depending on your antenna, you may require big capacitors or the ability to shunt in a fixed one. Anyway, So what we do first on a differential tuner is we basically turn the inductor, and on this tuner I'm looking for any change. Now normally I would just look for a reflected power change, but I've found on differential tuners that that doesn't really give me the information I need. Normally I'd look for the reflected power to go down rather than the forward power to go up, but you know, on a differential tuner, sometimes it doesn't happen, especially when I've got that set to the middle, which is the capacitor halfway meshed into the input and halfway meshed into the output. And that's I guess the recommended position for almost every band in the manual. Sometimes it says like 46 and 45 and 47, and you're sort of thinking, why not just say 50? But anyway, so we'll go and do that again, and we'll roll it down, and hopefully you'll see the forward power is going up there, and it keeps going up a little bit, and then it stops moving anywhere. Now when it stops moving, and I keep going, and I'm not seeing any further progress to any real extent, that's when I roll back a little bit, and as I said, this is when I'm first trying to find a match to the point where I start getting movement. And that's when I know something's happening. So we'll leave it there, and we'll move over to the differential capacitor. Now, as I mentioned previously, normally it's advantageous to run as much output capacitance as possible. But that said, you know, your match is going to be where it is. So what I would do because of that is try moving towards this way, which is more output capacitance, and you can see the forward power is going right down. So that's certainly not the direction we want to go. We will go back this way, and you can see quite quickly that that reflected power is dropping, and the radio is actually putting out the full 50 watts. I'll just go back a bit just out of interest, and let's have a look. So basically at about, according to the meter, somewhere just past 3 to 1 on this meter, the radio starts folding back. And that's what you have to bear in mind is we're only running 50 watts. So, you know, radios won't fold back as quickly when you're running reduced power. So we'll keep going back just a little bit more. We'll keep tuning, go all the way down, and we find it actually stops and comes back up. It's sort of like a bit of a parabola of sorts, I guess. Now, don't go too fast, or you can fool yourself into, you know, it bouncing around. Like, I'm trying to get an example here, but where is it? You know, you can sort of either miss the, you know, you can get it to swing right down and it looks good. So you don't go too fast. You go nice and slow. And right where, I guess, the top of the parabola is, or whatever, you know, the bottom is, where it's bouncing back and forth, you leave it there, and then you go back to your crank, and you'll move your crank one way and it'll go up, and then you'll move it the other way, it'll go down a bit, back up. Once again, find the middle spot of there, and then go back to this knob and do a little bit of fine tuning, see if we can get anything more out of it. In this case, it doesn't look like it. We'll turn the radio off, so give me 1 second, I'll stop sending. And you can see there's no movement there in the reflected power, which means we've basically matched our antenna, which did have, I guess, well, somewhere around over a 3, somewhere between a 3 to 5 to 1 SWR on the transmission line to a 50 ohm receiver. So there you go. Now, one other thing you can do is if you increase the power, and then we'll hit send again, you can see that the needle's still not moving, which means we really have got a good match. Now, matching a G5RV on 20 meters is not a particularly hard task, considering the G5RV was indeed designed for 20 meters. So let's try something different. What shall we try? They also work on 80 meters. So let's go and try 80 meters. So I'm just picking out a frequency here, bear with me. And we'll see if there's anything there. Nope. Put that into carrier mode. And yes, unfortunately, you do get a, when you're first finding your, your settings, you do spend a bit of time doing this, especially if you're giving an example video. Luckily, the antenna I've got here is essentially a dummy load outside. It doesn't receive well and it doesn't get out well. But what I should say is, once you've gone to the effort and found the good settings for 20 meters, write them down, because on a quality bit of equipment like this, if you want to tune back up for 20 meters, you've just got to take your knob to 36 and 236, and with a couple of tweaks back and forth, you'll be there in no time. So I've found a frequency on 80 meters, and a G5RV is electrically short on 80 meters, but I know that this tuner can match it. So we'll go put our settings back, and there's no cheat sheets here. I'm just doing this from scratch because I want you guys to see what I do, because it is quite hard. It is formidable to get a match on a manual tuner. And even though a differential's only got one knob and one crank, I wouldn't rate it as much easier than a normal T-match such as the AT2K. Okay, so got 80 meters on. Let's go send a carrier. Alright, so in this case, it's obviously much, much worse in terms of match. And we've got about 10 watts forward, and we have, allegedly over 10 watts back. And that actually can occur, because you've got standing waves, and the voltages and whatnot can build up on the line. So as I said, with the lower frequencies, you generally require more inductance. So we needed about 236 on 20 meters. Let's go right down and see what happens. So watching the meter all the time, and nothing's happening. And reflected is going down a little bit. Okay, so something happened around there, didn't it? Let's go back again. So I've got some action around there. Now that's a little bit inconclusive, because we've actually spanned quite a bit of territory there. So let's just say we're starting at 116. Sorry, we're starting at 136, and we go all the way to 123. We're at peaks, I guess, and then back down to 110, where it goes back to normal. So, all right, let's go to our peak on our forward power in this instance, and let's turn the knob, and we turn to anti-clockwise as normal, as suggested, trying to get more output capacitance, and we can see we're getting a dip straight away. So you can actually see that's quite a sharp dip. And by picking the forward power at the point where we had the most forward power, we were able to pretty much first go get, absolutely first go, get the right match. And it's 1, 2, 3, and in this case, about 67, I would say. I'll just stop that for the moment. So, there you go. Basically, the trick to using these tuners is to watch your meter, see what it's doing, and sometimes, I guess when you're fine tuning, you're looking to get that reflected power right down. That's what's telling you you're doing the right thing. The reason you don't always look at forward power is because as you make a match worse, reflected power actually adds to forward power. So the more reflected power you have, the more forward power you're going to have. So you're not always, increasing forward power in itself isn't always an indication of a good setting. What you want to see is increasing forward power without increasing reflected power, which is what we saw there on 160. Now, I'll show you an example of something this antenna tuner can't match, and we'll go back up. So that was 1, 2, 3. We've written those down so we never have to spend so much time on 80 meters again. This is one of the nicest things about a Palstar tuner is using the crank. Go back up. This one stops at about 248.5. Don't slam them because you can damage them. There is a video on how to deal with that. And we will move to, say, in this case, the 17 meter band. I'll have a quick listen. Nothing there, not surprising. And alright, we've got our 50 watts again. And I'll hit send. Now, I'll start off with inductor. We wouldn't be expecting much inductance, but let's find out. And we don't see anything at all, basically. Now, I know it's not going to be somewhere around 150. That's 40 meter or 80 meter territory, generally speaking. So, in this case, I'm sort of thinking, what the heck? So we'll go back to the minimum inductance, which is the highest number, 248.5, and now we'll play around with our capacitance, a differential capacitor. So going counterclockwise, I'll turn to the left, reduces the forward power but also the reflected, and going the other way. Okay, now we're seeing the right thing happen. Did you see that? When we went this way, your forward power went down, or your reflected power went down, but so did your forward, so there's no net gain. See that? No net gain. But when you go the other way, look at that, it's starting to drop. Okay, so we've dropped that down to, it's hard to read, but maybe about 1.3. The radio is certainly happy, it's putting out full power. But, I'm a sucker for punishment. I'd like to get that reflected needle right down away from 2.5 or 3 to nothing. So I'll start tuning this, and up it goes. And now my power's backing off. Alright, so let's just say I put it here and try it again. Nope. That's just the way it is. As it stands, this antenna tuner cannot get a match better than about 1.3 to 1 on the 17 meter band. So that's a limitation that you may be able to get around with a what was I going to say? An AT2K, so a 2 capacitor tuner. That said, I doubt it, because in this case, what's really limiting us is our inductance and our minimum level of inductance, and it just can't get low enough in this case. So anyway, I hope you've enjoyed the video. I hope that explains how to use a manual antenna tuner, and please, a differential antenna tuner at that as well. And please leave your comments or thoughts and comments in the comment section. This is Jarrad VK3BL saying 73 for Rate My Radio.